Are you getting some extra noise? Some screeching sound or not? I think okay. I think that sound is from my headphone. Yes. Yeah, can you please hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's good. Good. Okay, please. Okay. So I'm going to start the recording. Sorry, not feeling that good because um, you know after taking the booster dose, I got modern and it's a little bit painful. Yeah. So yeah, let me at least finish the class somehow. Anyway, so I'm going to share the audio. Enter screen. Good morning. In the previous lecture, we have discussed how to conduct hypothesis test by using the p-value approach. So p-value approach, this means we calculate probability. Yeah. So there are 6 steps as we have discussed in the previous lecture. So we will follow the same 6 steps approach for almost all kind of tests for this course. Now, at the beginning, when we try to solve any problem, especially that is related to hypothesis testing, we need to define the null and alternative hypothesis. We need to define null and alternative hypothesis. Then we think about the distribution to use. Now, to identify the distribution for the test, we need to think about few criteria. One of the key criteria is sigma is known or sigma is unknown that we have discussed here. Let's see the case 1, case 2, case 3. So in the previous lecture, we have solved a problem. When we solved a problem, we thought something like that. Especially for this specific problem, we identified key informations like the sample size, sample mean, the population standard deviation is known or unknown. If it is known, then what is that value? We found that is 7 here. Then the distribution. Now we identify the problem. This means the hypothesis to test. We define the null and alternative hypothesis. So that is now step 1. We define null and alternative hypothesis. In step 2, we need to identify the distribution for this test. To identify the distribution of the test, we use this kind of flowchart like stuff. So if sigma is known, then we follow either these two options. N greater than or equal to 30, then we use normal distribution and calculate Z statistic. If sigma is known, but N is less than 30 and distribution is normal, if both of these two conditions are satisfied, then we can use normal distribution and use Z statistic. When sigma is unknown, we wanted to discuss this kind of thing later. Okay, so essentially these criteria coming from here, case 1, case 2, case 3. Now think about case 1. What does the case 1 say? The population standard deviation is known. Sigma is known. This means sigma known. Then sample size small. Okay, sample size small. Population from which the sample is selected is normally distributed, but population distribution is normal. Is normal. Then in that case, we can calculate Z statistic. We can use normal distribution and we can calculate the Z statistic. That is case 1. Now, what does the case 2 say? Look at that. The population standard deviation sigma is known. Yeah. The population standard deviation sigma is known, but the other way around, sample size N is greater than 30, greater than equal to 30. So in that case, we can straightforward, we can see that we can use the normal distribution. Use normal distribution. And we can calculate Z statistic. Essentially, case 1 and case 2, these are drawn here. Yeah. And the third criterion is population standard deviation in sigma is known. The sample size is small. The population from which the sample is selected is not normally distributed or its distribution is unknown. So how to define this one? Sigma is known, but sample size is small, but population distribution is not normal. Is not normal. Then there is no option to use the Z statistic. We need to apply non-parametric method. Non-parametric method. Sorry, don't have a space here. It's non-parametric method. Yeah, that is not within the the first one. First part of this course, especially whatever we do in chapter, I can say 9, 10, 11, 12. We don't do anything about non-parametric test. We do something under chapter 15, probably. Yeah, we do some non-parametric test in chapter 15. So in the chapter, mainly we'll be focusing with these two options. That has been shown in this table. So sigma is known. Case 1, in less than 30, population is normal. Use normal distribution to test a hypothesis about mu. Sigma known. Case 3, sorry, case 2, n greater than or equal to 30. So you can use normal distribution for the test and calculate Z, right? And then we can calculate Z statistic. Then here, case 3, sample size small, population is not normal. Yeah, sample size small, population is not normal. This one. Only option is we can do the non-parametric test. We use non-parametric method. So most of the problems we are going to solve in chapter 9 will be from these two cases, not these two cases, not the third one. We'll do some tests for non-parametric methods. Yeah, we'll use non-parametric methods mainly in chapter 15. Okay. We have learned that when we do the hypothesis test, we need to define the null and alternative hypothesis that we have done here. We have defined the null and alternative hypothesis. Then we decided about the distribution to use for this test. So how to make the decision for distribution? We can follow this criteria. So based on the information we got, we identify that sigma known, then what is the value of n? Sample size, that is 20, this means n less than 30. So when the sample size is small, we must have to satisfy the second condition, that is the population distribution is normal. If n less than 30, we must have to have normal population. So in that case, n less than 30 and population is normal, so we can use Z. That has been mentioned here. So in our case, sigma known, n less than 30, but population distribution is normal. Yeah. So you can use normal distribution and calculate Z statistic. That we have done here. In step 3, we have calculated Z statistic. Then if you use the p-value approach, you can calculate the p-value. That we have done here. We have calculated p-value by using this procedure. Yeah. So how to calculate the p-value? So we have discussed in the previous lecture. Yeah, we can do again a little bit. Look at that problem. So is it a two-tailed test or one-tailed test?
Two-tailed.
Two tail.
Two-tailed.
It's a two-tailed test. So first thing that we need to do, okay, it's a two-tailed test. So region would be on both tails. Let's say the left tail or on the left, right tail. Now, what is this value? This value is then the calculated value, right? Negative sign, so that is coming to the left tail, and positive sign is with the right tail. So I need to identify this area. Essentially, that will be the probability from the left tail, and this area will be the probability from the right tail. So what I have to do, I have to add this part to obtain this result. So that has been done here. So we can calculate the probability as in step 4. Calculate the p-value. Yeah. Now we can make the decision in step 5. Essentially, that is step 5. Step 5, we can use the decision rule. Reject null hypothesis if p-value less than equal to alpha. In that case, we found alpha is equal to 0.01. So our p-value is less than alpha, so we reject the null hypothesis. Essentially, that is the step 5. Yeah. Then step 6, we write the conclusion. So how to write the conclusion? We have rejected the null hypothesis, so we have two hypotheses, null and alternative. If you have rejected the null, then what is remaining?
Alternative.
Alternative. Okay. Now write something about your alternative. Write something in favor of your alternative. So this means we may conclude that mean learning time for the food processing is different from 90 minutes. You can write in your own words, that's okay. But the key phrase should be something like that, because you are just rejecting the null and you have this to make the decision. Yeah. We also have done something like that. Okay, so we have learned how to work out with the p-value approach. Now, look at the critical value approach. I think we have also done this one in the previous lecture, right? We also have discussed this one. Yeah. So the markup is gone somehow, maybe. Yeah. So we also have discussed this one. Find the p-value for the test. So if you find something like that, this means we are supposed to follow the p-value approach. This means we need to calculate the p-value. Now, if you look at the problem statement here, what should you find from this part? A consumer agency that wanted to check this claim took a random sample of 36 members. So that is essentially n, right?
Yes, sir.
N equal to 36. Now, and found that they lost an average of 9.2 pounds. So what does
X
this
bar.
mean? X bar.
X bar.
9.2 pounds. With a population standard deviation of 2.4 pounds. S or sigma?
Sigma.
Sigma.
Sigma equal to 2.4 pounds. Now we are asked to find the p-value, right? This means we have to follow the p-value approach. Okay, whatever we do, we have to start with the null and alternative hypothesis. What is the null and what is alternative hypothesis here?
Null is 10 pounds.
Okay, So claims that its members lose an average of 10 pounds or more. Then what will be the null hypothesis?
Equal or greater.
Excellent. So null hypothesis is then, because that's the claim. Yeah, equality symbol. So mu greater than equal to 10. Now what is the alternative? Just with the opposite
Mu
sign.
less than.
Mu less than 10.
Yes, mu less than 10. That we have done here. You can see we have defined the null and alternative hypothesis. In the step 2, what shall we do? We need to think about the distribution, right? We need to think about the distribution. So you can now look at the options. Yeah. Or if you wish, you can see something like this as well. So even if you follow this one, where we are heading to, think about that. Sigma is known, n greater than 30. Just look at that. Sigma is known, n greater than 30. So sigma is known, n greater than equal to 30. So we'll be using normal distribution, right? We use
Yes,
normal
sir.
distribution and calculate the Z statistic. Okay. First, these expositions have been provided here. The population standard deviation sigma is known. So you can say now sigma known. Then again we find n is greater than 30 in our case. So what shall I do? You can do central limit theorem. We use normal distribution. Okay, we say we use normal distribution, but normal distribution for what? Normal distribution for x bar. Keep in mind. Then we can calculate Z statistic, right? Yeah. So you can now follow through. In the next step, step 3, we calculate Z statistic. Now, yeah, Z equal to, as you know, Z equal to x bar minus mu by sigma x bar. Yeah, that's the formula. So here we have calculated sigma x bar. Then we inserted the value of x bar, mu, and sigma x bar in this formula, and we calculated Z equal to minus 2.00. So x bar, that is already provided. Now, mu, what is the value of mu?
10.
10.
Why this is 10? You're correct, 10, but why?
Because muta always null hypothesis মানে ইয়াটা নিতে হবে
Excellent,
ভ্যালুটা
excellent. That is the reference value in the null hypothesis, right? Good job, good job. Yeah. So we use mu equal to 10. Excellent. Yeah. Now we got the value of Z. So step 4, we need to calculate p-value. Now how to calculate p-value? At first we have to draw something like that. Okay. You don't need to be very, well designed and a good designer, a good artist to do that. Just to do freehand drawing. As long as you make this understandable to yourself, that's fine. Yeah. Okay. So this is left tail test, right? Left tail test. So the rejection region would be on the left side or right side? On the
Left.
left side. So the p-value is essentially this area. Okay. Now, what is the calculated value here? Minus 2.00. Minus 2.00. So P value would be probability of this area is less than minus 2.00, right? Any value to the left side of this bar is less than 2.0, minus 2, minus 2.00. So this is now Z less than minus 2.00. You can use the statistical team to calculate that probability. Minus 2.00. I think yesterday you got 0.02, something like that, yeah? 0.0228 minus 2.00, so 0.0228. 0.0228. That is essentially 0.0228. Yeah. So we got the p value, right? We got the p value. Now the decision, step 5. Step 5. So rejection rule, reject null hypothesis if p value less than equal to alpha. In our case, what we can write? Alpha is 0.05. Okay. In our case, when alpha equal to 0.01,
We do.
Null hypothesis accepted when a equal to 0.1.
yes. So when alpha
In
equal to 0.01, then
we reject.
p value is not equal to alpha, right? So do not reject. Now, when you use alpha equal to 0.05, in that
We
case,
reject.
p value less than
Reject.
equal to alpha, and you reject the null hypothesis. Okay. And you already have learned how to write the conclusion. So if you reject the null hypothesis, then you will have only the alternative. So you can write something about your alternative hypothesis to comment on, yeah, or to write a conclusion. If you do not reject the null hypothesis, then you can talk about your null hypothesis. Yeah, you can see here the difference of writing the conclusion when alpha equal to 0.01. We did not reject the null hypothesis. That is why we conclude that the mean weight loss within the first month of membership by the members of this club is 10 pounds or more. Yep. That's completely about null hypothesis because we did not reject the null hypothesis. Then when we reject the null hypothesis, we talk about the alternative. So therefore, we conclude that the mean weight loss within the first month of membership by the members of this class is less than 10 pounds. So because you have rejected null, so you have only the alternative. So that part is essentially step 6. So step 6, conclusion. I mean, essentially, that will be step 6. The conclusion, sorry. That is step 6. So you can write from here. Essentially, that is the conclusion. So far we have learned how to do the hypothesis test by using the p-value approach. Now, if you follow the critical value approach, you just do almost similar stuff, excluding step 4 in that way. We calculate critical values. When you use p-value, When you use p-value approach, we calculate probability. When we use critical value approach, we just use the critical values. That's it. Most of the stops are exactly as it is. Let us see one problem with critical region. And yeah, so until this point, we have essentially reviewed the stuff that we have done in the previous lecture. So we are moving forward with the critical value approach. Same procedure, null and alternative hypothesis, distribution to use, then yeah. So at first you have to state null and alternative hypothesis, then we need to select the distribution to use, then we determine the rejection and non-rejection region. I would prefer to use the calculation of test statistic in 3, then yeah, 3 plus 4 by the rejection region, 5, 6 there, 7. Okay, let's follow the same procedure. The TIP telephone company provides a long distance telephone service in an area. According to the company's record, the average length of all long distance calls placed through this company in 2009 was 12.44 minutes. The company's management wanted to check if the mean length of the current long distance calls is different from 12.44 minutes. The company wanted to check. Okay. A sample of 150 such calls placed through this company produced a mean length of 13.71 minutes with a population standard deviation of 2.65 minutes. Now, this is the most important sentence to find most of our information. So n equal to
150.
Then mean, that's mean length found, x bar equal to 13.71 with a population standard deviation of 2.65 minutes. Sigma equal to 2.65. Okay.
Sir, n
Nothing is
equal to 150.
150. Excellent. Yeah, I missed it. Thank you very much. Yeah, 150. Now, we need to define the null and alternative hypothesis. So, what shall we do? Here you can see it's asked to check, right? The company's management wanted to check if the mean length of the current long distance calls is different from. So which one should I write before? Null or alternative?
Null.
Different from, so not equal to, right? So that's the alternative one. Like if you are asked to do the test, that the test becomes the alternative. Test this is different, or check this is different, or check this is less than, or check this is more than. If something is claimed, that becomes the null. So not equal to, so mu not equal to 12.44. So null is then mu equal to 12.44. Okay, so look at that. Step 1, step to go. Now step 2. See here, sigma known n greater than 30. So what shall we do? Same procedure here. Sigma known n greater than 30, so use normal distribution for x bar, and we calculate z statistic. You can write by using a flowchart like this, or you can also use the statement in that way. It's up to you. Okay. So we found that sigma is known. Then we found that n greater than 30. Then what we can do is essentially tells that use normal distribution for x bar. And then we calculate Z statistic. Sorry, yeah. Now in step 3, we calculate Z statistic. Yeah, I don't want to write in that way, so I'm going to cross it out. I would like to write, no, not here. Step 4 is coming here. Done. So what I can do, okay, I don't want to overwrite too much of thing. So I can just write the step 3 here. So step 1, I have defined the null and alternative hypothesis. Step 2, we have decided normal distribution to use, and we are going to calculate Z statistic. Now let us calculate the Z statistic. Yeah, I can even write here. Z statistic, so Z equal to x bar minus mu by sigma x bar. So we need to calculate sigma x bar. We can do that. So sigma x bar, calculate sigma x bar. Sigma by square root of n. The value of sigma is 2.65. Square root of 150. So you can find the sigma x bar. If you have calculator, you can try to find it.
0.2163.
0.163, okay.
2163.
2163. Yeah. Now we can put the values here. X bar, we got 13.71. Minus mu from the null hypothesis, that is 12.44, divided by sigma x bar, that is 0.2163. So you can find the value of Z. Yeah. That has been calculated here. So 5.87. Let's say that is 5.87. 5.87. 5.87. So you got the value of Z. Now, what we did in the previous problem, we followed the p-value approach, and so we calculated the probability. In this problem, we are going to use the critical value approach. Yeah. So using 2% significance level, can you conclude that the mean length of the current long distance calls is different from this minutes? Yeah. So you are asked to test like that. Yeah. Different from this minutes. That is how we defined the alternative hypothesis in that way. So this is a two-tailed test, right? This is a two-tailed test. And we are going to use the critical value approach. So how to do that? Step 4. I'm doing step 4 here. Step 4, identify critical value. In the previous problem, we calculated p-value under the step 4. And now, in the 4th step, we are calculating the critical value. How to do that? At first, you need to think about the alpha. So value of alpha, that is 2%. 2%. This means alpha equal to 2%. So use the proportion 0.02. Now it's a two-tailed test. So we'll have rejection region on the left side, right? Two-tailed test.
Sides.
Both sides. Excellent. Yeah. We'll have that on the both sides. Good job. Yeah. We'll have that on the both sides. Okay. So you got it. So we'll have that on the both sides. Now, how to identify that region? So alpha is 0.02. So alpha will be divided in 2 days. So alpha divided by 2. This means 0.01. This area is 0.01, and that part would also be there. Alpha by 2. 0.01. So that area is the rejection region. That is the rejection region. Okay, I have to find this value. So when we calculate the p-value, we use the value of z and calculate the area. Now we are using the different procedure. We know the area, or we fix the area, then we find the value. So these values are then the critical values. So how to find that? We can use the statistical table to do that. We can use the same table. Look at to get it. 0.01. Alpha by 2 equal to 0.01. So 0.01, we have to look up here. So 0.01, if you look from the beginning, it's increasing, right? So 0.01, yeah, somewhere around 0.01. So look at 0.01. Sometimes you may not find the exact value. You may find the closest one. So select the closest one. So this one, 0.01. I mean, approximately 0.01. Or yeah, this one is the closest one. This one is 0.0102. And this one is 0.0099. So this is the closest one. So we can select the minus 2.33, right? Minus 2.33.
Sir,
Yes, please.
sir, so suppose the value was 0.0101. So আমরা কি like কমটা চুজ করব না বেশিটা? Like difference the same হয়েছে।
Yeah, then you may choose the higher value, or you can come between these two if they're exactly same, like 0.01. Yeah, if your problem is like that 0.01, then they are exactly the same, right? Same difference between
Yes, sir.
0.01. So you can come to the middle. So this means minus 2.325, right? So minus 2.32 and minus
Yes.
2.33. In that case, you have to be between that. So minus 2.325, something like that. But here we find that this one is the closer than this one. So you can choose this one, minus 2.33.
Okay.
If their difference is same to the left side and the right side, then come to the between. I can show you one example. Point 0.05. Let me show you, or 0.01. There is something like this. This one is exactly so 0.05. This one, see here, same difference. Did you see? If you look at 0.05, so difference between this one and 0.05 and this one is the same. So you can come between two. So minus 1.645. That is how you will find in many places. When alpha by 2 equal to 0.05, then we use minus 1.645. Okay, so we are using, for this one, we are using 2.33. 2.33. Minus 2.33. I think this has been shown here as well. Yeah. So minus 2.33. That is the left critical value. And what is the right critical value? Opposite sign, right?
2.33.
Yeah, positive sign. Positive sign. Now, how to make the decision? Step 5. So reject null hypothesis if calculated value in the rejection region. Rejection region. Okay. So we have two rejection regions, this part and this part, like the shaded area. Now what we can see from here, Z equal to 5.87, where that value is falling in. Z equal to 5.87. 5.87 is falling somewhere in that place, right? 5.87 in that region. So you can see Z is following here. So you can find that since Z equal to 5.87 maybe. 5.87 falls in the rejection region. In the rejection region, we reject the null hypothesis. We reject null hypothesis. So the shaded areas are the rejection region, and non-shaded area, this area is the non-rejection region. Okay. So here, so these are the rejection region. We found that the Z value, our calculated value of Z, that is falling on the rejection region. So we reject the null hypothesis. Now, step 6. So once you reject the null hypothesis, what shall you do? What is your conclusion? Yeah? Can anyone please let me know? What is the conclusion? You have rejected the null hypothesis.
So I accept the alternative hypothesis.
Yes. Then what do you want to say from there? What the alternative says? Different from
Different from 12.44.
12.44. Yes. Yeah. Different from 12.44. So you can just write the conclusion here. Step 6. Just write your conclusion. And here will be the step 6. And conclude that. Hence, we reject the null hypothesis and conclude that. That makes your step 6. Yeah. So when you practice by following the answers here, means my answering procedure, you can see you don't need to write too much of thing. You can solve one problem just in a single page. So you can take an A4 size page and only within one side, not in both sides of that page. You can solve one problem just in one side of the page, because you don't need to write too much of that. Just follow the procedure. Yep, follow the procedures and start writing in that way. It's easy. It's not too long. Yeah. Okay, let's see the next one. I think after that we'll move to the other problem related to sigma is not known. Sigma is not known. Okay, so here we did it. Yes. Now it's your turn. The mayor of a large city claims that the average net worth of families living in the city is at least $300,000. A random sample of 25 families selected from this city produced a mean net worth of this. Now, after reading up to this point, I can identify key information. So the key informations are, so the key information I can find, that is the n. I found n equal to 25. Then what is that value?
X bar.
X bar, yeah, X bar equal to $288,000. Okay. Assume that the net worth of all families in this city have a normal distribution. So population distribution, normal. Population distribution, that is the normal, right? We got population distribution normal. With a population standard deviation of 80,000. So you can see, assume that the net worth of all families in this city have a normal distribution with a population standard deviation of 80,000. So what does this mean? Sigma equal to 80,000. Using 2.5% significance level, can you conclude that the mayor's claim is false? So we are going to test the claim. So what is the claim? At least.
Sir, H not greater than equal 300.
Greater than equal.
Excellent, excellent. So your null hypothesis is that. So alternative is then so you got your null and alternative hypothesis. Yeah. Now I have to make decision for the hypothesis, means I have to select the distribution, right? Select the distribution. So you can follow the path. We already have sigma known. Sigma is known, as you can see. Sample size n less than 30. Now we have to check. If n is less than 30, we have to check the distribution. Population distribution, normal. Is normal. So what we can do? We can use normal distribution for x bar. Then we can calculate Z statistic. Okay. So step 2, we have decided to use the Z statistic. Now in step 3, we can calculate the value of Z. So I'm not going to use this one. Step 3, I'm going to follow the same procedure from the beginning. Z equal to x bar minus mu divided by sigma x bar. I can calculate sigma x bar here. Even during the exam or when you take the notes, you can use this kind of vertical sign to the right side of your answer script or whatever to do some extra calculation that helps to refine the other calculation. So you can do that, like so x bar equal to sigma divided by square root of n. So now I can put the value of sigma, that is 80,000 probably. 80,000 and n equal to 25. Okay, so square root of 25. So if you have calculator, please try to find the value.
Sir, 16,000.
16,000, yeah. 16,000. Now put the value of x bar. X bar is 2,000, sorry, 288,000 maybe. 288,000. Okay, so 288,000 minus the mu is 300,000 divided by sigma x bar, that is 1600. Sorry, 16,000 essentially. So you'll be getting the value of Z.
So minus 0.75.
Minus 0.75. Okay. Minus 0.75. I mean, this calculation has been done here. You can see. So I'd love to write this as step 3 essentially. Where my cursor gone? Yep, it is. So that is essentially step 3. Okay. So that's my step 3. Now, under step 4, what shall I do? Step 4, I need to identify the rejection region. For the p-value approach, I shall calculate p-value. For the critical value approach, I shall identify the rejection region. So I can do that very easily. So here, step 4, I can try my best to fit in here. So alpha, what is the value of alpha? Alpha equal to 2.5%. So 2.5 divided by 100. So 0.025, right? Alpha equal to 0.025. Now, do I need to find alpha by 2?
No, sir.
Why?
It's a left tail test.
Excellent. That's a left tail test. So whole alpha is on the left side. Yeah. Whole alpha is on the left side. Yeah, whole alpha will be the left side. So that will be my rejection reason. Yep, rejection reason. Alpha equal to 0.025. So this is a left tail test. So the rejection region will be on the left tail. Yeah. And whole alpha will be on the left side. So alpha equal to 0.025. Excellent. So let's find 0.025. Now searching in the ocean, right? 0.025. Yep. Luckily we got it. As a whole number, 0.025. So that corresponds to minus 1.96, right? Minus 1.96. Or you can count in that minus 1.90, 1, 2, 3, 4, 5, 6, minus 1.96. We got it. Minus 1.96. Minus 1.96. Yeah. Where we got it? Yep, here's minus 1.96. Minus 1.96. So the rejection region is on the left side of minus 1.96. Where is our calculated value from? Our calculated value z equal to minus 0.75. So midpoint around the peak is 0, right? This point is 0. So minus 0.75 would be somewhere around here, right?
Yes, sir.
Yes, sir.
So this means the calculated value of z is falling somewhere in the, maybe here, non-rejection region. So should we reject or accept?
So accept now.
Accept.
Accept null hypothesis. We talk about the same thing, but we prefer to talk in terms of either accept, either reject or do not reject. Okay,
Do not
so that's the
reject.
statistical term. Of course, Trump is very good at doing that. Do you remember? He told once, like, this morning I tested positively for COVID-19. This means I got the negative result. Yeah, if you tested negative, that's positive for you, right? Good for you. So yeah, somehow in that way. So step 5, right? Now what we can say, since the calculated value falls in the non-rejection region, so we do not reject the null hypothesis. Since it falls in the non-rejection region, so we do not reject null hypothesis. Yeah. Okay. Yeah. So we got it done. We do not reject null. Then what shall we do? We do not reject. This means we talk about null. That is the conclusion. So null says more than $300,000. So you can now write the conclusion in that way. Therefore, we can state, yeah, you can see, therefore we can state that based on the sample information, it appears that the mean net worth of families in this city is not less than $300,000. I mean, why they wrote in that way? So that is because of that assumption. Can you conclude that the mayor's claim is false? So false means greater than or equal to 30, the opposite of that. Yeah. So that is wrote in this. That is why it is written in this way. But if you would like to avoid the confusion, you can follow the same procedure for all hypotheses. You can just look at, we do not reject null hypothesis, so just we talk about the null hypothesis. This means the mean, what can I say? What is that essentially? Yeah, the average net worth or the mean net worth of families living in the city is more than $300,000, or at least $300,000. You can say $300,000 or more. So it's up to you. You can write in your own words, but you don't need to write too many things. Just write a single line. That will be fine. So is it clear to you how to do the hypothesis test for critical value approach? Hypothesis test for mu. This means the mean by using the p-value approach, and another one is the critical value approach. I think you can do that quite easily. Yeah. Okay, so there. Yes, let's see one more example. I will not complete that one. I will discuss a little bit, and in the next lecture, I will complete it. Just I shall provide some insight. Now, think about the case here. Whatever we have done so far until this point, we found that sigma is known. We found that sigma is known. But what happens if sigma is unknown? Procedures are exactly the same. Only difference is in the distribution. Yeah. Yet even the step 2 is the same, but we do not use Z. We use T. Let's see. Here it is. Okay, so from what we can do, if we look at this issue, sigma is known, then case 1, case 2, case 3. Yep, we'll have the same thing. Sigma is unknown. We'll have same case 1, same case 2, same case 3. Only difference is we use T distribution to test the hypothesis. And it is the same. Third number 3 is the same. We use the non-parametric method. So is it not clear? Just the same thing. Same criteria, same evaluation. We wrote sigma unknown. And when sigma is not known, we'll just write sigma is not known. Case 1, whatever then. Here, only difference here, we use T distribution to do the hypothesis test. Yeah, we use the T distribution and we calculate T statistic. That will be here. You can see from here, hypothesis test about mu when sigma is not known. Possible cases, essentially they are same, only difference is here. If sigma is not known, and you can see, we use T distribution, only difference in the T. Yeah. We found the difference only with that word and with that word. Case 3 is exactly as it is. So when we do the test, we calculate the T statistic. And calculation of T statistic is the same. Look at that. You do not know sigma. So what shall we do? Sigma is the population parameter, right? We can always estimate population parameter by using the sample statistic. So S is the sample statistic. So whatever happening here, think about it. We used Z equal to X bar minus mu divided by sigma X bar. We are using T equal to X bar minus mu divided by S X bar. First we are replacing sigma by S. Same thing happens here. Yep. If you look at that, Z equal to X bar minus mu by sigma X bar that we used in the previous problems. And sigma X bar equal to sigma divided by square root of n. Now we do not know sigma, but we know sample standard deviation. We do not know the population standard deviation sigma, but we know sample standard deviation S. So what we have done, we have just replaced sigma by n. We have replaced sigma by S. And we got the T. You can just see they are exactly the same. Only difference is sigma and S. So sigma has been replaced by S. You can see also here. Sigma has been replaced by S. That's it. So computation of statistic is really very easy, as same as before. And the distribution, assignment of the distribution is more or less the same. Only thing is that sigma is lower than low. So we'll look at a problem here. A psychologist claims that the mean age at which children start walking is 12.5 months. Okay. Carol wanted to check if this claim is true. She took a random sample of 18 children. She took a random sample of 18 children. So what is that now?
N.
Yeah, n equal to 18. So she took a random sample of 18 children and found that the mean age at which these children started walking was 12.9 months. Now there is no.
S
So
bar.
12.9. Yeah. So you can see again here. She took a random sample of 18 children and found that the mean age at which the children started walking was 12.9 months with a standard deviation of 0.80. So from
S.
where the standard deviation coming? It does not mention
Sample.
population standard deviation.
Sample.
It's coming from the sample of 18. Yeah, that's sample. Excellent. So it's now S equal to 0.80. It is known that the ages at which all children start walking are approximately normal distribution. So distribution is normal. So population distribution is normal. Yep. Find the p. Sorry. Find the p-value for the test. Yeah. So you have to follow the p-value approach. Yeah. Find the p-value for the test that the mean age at which all children start walking is different from. Now, from here, what can you say?
This is an alternatives.
So what is the alternative?
Not different. Not equal.
Yes, mu not equal to 12.5. And null is then just the opposite side. Yeah. So you got it now. So yeah, we defined the null and alternative hypothesis. We have done that. Now the step 2. Here we found, at first we assess the sigma. Sigma is known or unknown here? Unknown. Sigma is unknown. Then sample size small, but population distribution is normal. N less than 30, but population distribution is normal. Oh, sorry. Population distribution is normal. sorry. Yep, population distribution is normal. Then, yeah, what we can say, sigma is unknown, or you can say sigma is not known. It can be consistent with sigma is not known, not sigma is unknown. That's same essentially. Sigma is not known. Or sigma is unknown, that's same essentially. Okay, now if you follow through the footstep, sigma is not known, n less than 30, population is normal, use the t-distribution, yes. So we use t-distribution. Distribution, so you calculate the statistic. Okay, we have decided to calculate the t-statistic. Let's do it. Step 3, we calculate the t-statistic. Yeah. So we calculate Sx bar. I mean, yeah, we have already seen that. How to calculate t. Calculate Sx bar and calculate t by using this formula. We'll get 2.121. 2.12. Now we want to find the probability, right? We need to find the probability. Okay. So when we calculate that, we need okay. Yeah. Step 4, we want to calculate the probability. So under step 3, we calculated the value of t. In the previous problems, we calculated the value of z. Now step 4, we calculate the probability. Yeah. Find probability. Or you can say find the p-value. Now, in order to find the p-value, we need to find the degrees of freedom. So df, essentially that is degrees of freedom. Degrees of freedom for that is n minus 1. This means sample size minus 1. So you got 18 minus 1, that is equal to 17. Now that is the value of t. We need to find the value of, we need to find the p-value. So how to find that? I mean, if nothing is mentioned about the p-value or critical value approach, it's better to use critical value or t-statistic or t-test. Why? The reason is you may not find probability corresponding to every possible combination of t and degrees of freedom in the table. Yeah. So what we can do, look at, yeah. So degrees of freedom 17 is the standard normal distribution table. Let's find the t distribution table. That's the t distribution table. Okay. Keep in mind, t-distribution table always provides the value from the right side. This means it always provides the right critical value. Here, for the normal distribution, it provides the left critical value and result from the left side. For t-distribution table, it provides from the right side. Okay. Now, look at the value. 2.121. With 17 degrees of freedom. So 17 degrees of freedom. At first look at 17. So you see the 17 degrees of freedom in this row. Degrees of freedom. So look at that. Degrees of freedom. So 17. Degrees of freedom. Then this means I have to look at this row. I have to look up the row corresponding to degrees of freedom 17. Now, where is the value of t is falling in? 2.121. 2.121.
Sir, ওইটা 16 আছে স্যার।
2.121 here, right? Now, but I have to look at, because the degrees of freedom is 17, so I must have to look at in that row. I have to follow only in that row. Yeah.
0.025.
So the value is 2.121. 2.12 is greater than this one, right?
Yes, sir.
But less than this one. This means 2.121 is falling somewhere here. Is falling somewhere here. Now go to the corresponding probability, the tail probability. So this means the corresponding probability is also falling between these two values, 0.025 and 0.01. Is it not clear to you?
Yes, sir.
Yeah. Okay. So now we are using probability between 0.025 and 0.01. 0.025 and 0.01. So zero point zero two five and 0.01. Then why do we say 0.02 and 0.05? Because it's a two-tailed test. And the table shows for the only for the right tail. So if you would like to make it two-tailed, then multiply it in by 2. So that is why this will be 0.05 and this will be 0.02. That is why it wrote p-value is between 0.02 and 0.05. I'm repeating this again. So you got degrees of freedom equal to 17. You got degrees of freedom equal to 17. So you have to look at the row with degrees of freedom 17. Only that row. Now I need to find the value. This I need to locate the value of t. So 2.121, where that is falling in. So 2.121 in that row. Let's find the interval. So that is between 2.110 and 2.567. So go to the corresponding probability, that is 0.025 and 0.01. So which one is the smaller? 0.01, right?
Yes, sir.
So your p-value is between 0.01 and 0.025. So your p-value from the table is 0.01 and 0.025. But you are using a two-tailed test, so you have to multiply. So for the right, from the right tail, we found that is from the table, (0.01) less than p-value less than 0.025. Okay, that is for the right tail. So multiply by 2. Or two-tail test. From the table, we got 0.01 to 0.025, but we are doing a two-tail test, so we are multiplying that result by 2. So we are getting p-value is between 0.02 and 0.05. Now, how to make the decision? 1% level of significance. So this means alpha equal to 0.01. Alpha equal to 0.01. So in order to make the decision, we need to compare the upper value, right? Yeah, the highest value in the range. So the upper range in the probability is 0.05. We can see that alpha is less than that. Alpha is falling within this range too. So even if you look at that, alpha is even less than the lowest value in the p-value, lowest p-value. So we can reject or accept. If p-value is less than alpha, we reject. But here what happens? P-value is greater than alpha. So we do not reject the null hypothesis. For any alpha greater than 0.05, we reject the null hypothesis. Why? Because we always consider the upper p-value. If p-value is within the range, we should always consider the upper one. So the upper value in the p-value range is 0.05, which is greater than alpha, so we do not reject the null hypothesis. Okay. For any alpha less than these, we will not reject the null hypothesis. Whatever doesn't matter. Yeah. Now, even if you consider for any alpha less than 0.02, we will not reject the null hypothesis. Yeah, sure, because our previous lowest range even in that. Yeah. For our example, alpha equal to 0.01, which is less than the lower limit of the p-value range of 0.02. As a result, we fail to reject the null hypothesis and conclude that the mean age at which all children start talking is not different from. Okay. So we essentially compared both of them. Yeah, compared both of them. Now what happens if alpha equal to 0.10? If alpha equal to 0.10,
We do not reject.
we reject them. Then p-value is less than alpha. If alpha equal to 0.1, then p-value would be less than alpha. Either the lower bound or upper bound, both will be less than alpha. So we can then reject. But in our case, alpha equal to 0.01. Alpha equal to 0.01. That is less than even the lower bound of p-value range. So we cannot reject the null hypothesis and write the conclusion in that way. Yeah. So I think at least we got an idea how to work with T distribution to do the test. I think we can stop here today. Any question, please? If there is no question, then I think I can go for the attendance in a moment. So, 1 moment, please. Attention, please. Abdul Rahman Rojin,
Present, sir.
Anika Tahsin,
Present, sir.
Ashish Vishwas,
Present, sir.
Ayman Arafat,
Present, sir. Present, sir.
Asmain Shadid,
Present, sir.
Bilal Hossein,
Present, sir.
Vishal Shah,
Present, sir.
Ritik Samuel Purification,
Yes, sir.
Ismat Jahan Sania,
Present, sir.
Izharul Islam Iraz,
Present, sir.
Jerin Tasnim,
Present, sir.
Kashfia Hussein,
Present,
Kashfia.
sir.
Yeah,
Present,
okay.
sir.
Yes, I got it. Abu Bakar Siddiq,
Present, sir.
Ashikur Rahman, Ashikur Rahman, Mohammad Shadman Sakib,
Present, sir.
Tanvir Hassan Shobuz,
Present, sir.
Afroza Nasrin Laki,
Present, sir.
Momita Paul Chaudhary, Momita.
Present, sir.
Yes, okay. Nafisa Tasfia,
Present, sir.
Muqtada Al Sabah,
Present, sir.
Nafisa Tabassum,
Present, sir.
Nusrat Jahan Senior,
Present, sir.
Probal Kumar Dotto,
Present, sir.
Rabbi Hassan Albi,
Present, sir.
Radia Tanzil Prapti,
Present, sir.
Rahatullah Chaudhary,
Present, sir.
Raisul Islam Bhuya,
Present, sir.
Rashik Ahmed,
Present, sir.
Rishad Rahman Bhuya,
Present, sir.
Rubaiya Jannat Oritri,
Present, sir.
SM Ridwan,
Present, sir.
Sadia Sharmin Malia,
Present, sir.
Sami Hanaz,
Present, sir.
Sarkar Said Kabir,
Present, sir.
Shadab Hossein,
Present, sir.
Sami Hamim,
Present, sir.
Sheikh Shihabur Rashid Shihab, Shihab, Subha Salam Athoy,
Present, sir.
Tahmid Shihab Burshid, Tarab Mahbub,
Yes, sir.
Tasfia Tasnim Jaman,
Present, sir.
Tasmim Tabassum,
Present, sir.
Tasnuba Binte Tarek,
Present, sir.
Jerin Tanzim, yeah, Oshorcho.
Present, sir.
Okay.